All right, good evening. Welcome back to Calculus 2. So we are looking at the alternating series, -1 to the n squared over n cubed plus 2. Okay, so first thing is, yes, it's a series. Two, it is alternating. So we're going to try to set up for the alternating series test. In order to do that, we have three conditions to make, and that is that my a sub n's are greater than 0. So if I look at my n squared over my n cubed plus 2, for n greater than or equal to 1, we're going to be able to say that n squared is going to be positive. And then for positive numbers, we cube them, they're still positive. Add 2 to it, it's still positive. So all of my a sub n's are going to be positive numbers. And then the only negatives are going to come in is like every odd term is going to be 1, 3, 5, 7, and 9. They're going to be negative. Okay, so check off on the first little condition there. We do have a sub n's are greater than 0. Two, is it a descending function? So a decreasing function. So what we're going to do is I'm going to go ahead and make an f of x equal to x squared over x cubed plus 2. And again, you can use the product rule, you can use the quotient rule. Okay, this time let's go ahead and try the quotient rule. Just going back and remembering the quotient rule is derivative of the first times the second minus the first times the derivative of the second all over the second thing squared. Okay, so that's just going back and remembering how that actually works. So we can go ahead and say, okay, this top part is the f is equal to x squared. My g is equal to x cubed plus 2. And we just plug in as we go here, okay? So f prime is going to give me 2x. My g is going to be x cubed plus 2 minus my f is going to stay x squared. My g prime is going to look like 3x squared. Of course, the derivative of 2 is 0. And then divided by x cubed plus 2 squared. Do not multiply this out. Okay, just leave it alone. We're gonna see what happens. Now we do have to kind of figure out what's going on with the top. So what I'm going to do is I'm just going to distribute this out to kind of see what we're working with here. So I've got a 2x to the fourth plus 4x minus, and then we have a 3x to the fourth up here. And on the bottom, we still have an x cubed plus 2 squared. Okay, if I go through the top here, we have 2x to the fourth minus 3x to the fourth. That's going to be 4x minus 2 minus 3 is going to be -1. X to the fourth, x cubed plus 2 squared. Now, the bottom I know is always going to be positive because it's a squared number. Where is the top going to, is the top going to be positive or negative? So I want to do is say we have 4x minus x to the fourth, set that equal to 0 and see what's going on with that. So we go ahead and say we have x, we have 4 minus x cubed equals 0. So we have x equals 0 or x to the cube equals 4, or equivalently, x equals the cube root of 4, which I believe is like 1 point something. It's 1.5, 1.6, something like that. So again, when we are at the beginning of the series, it would be 1, so we end up with an increasing function. But for every number after that, so after 1.6, which would be 2, we're going to be decreasing. Okay, so we can go back up here and we can say, okay, this is going to be a decreasing number. So let's go ahead and say what's going on with this. So this is going to be after x is greater than or equal to 2, this is going to be decreasing. Okay, so we have negative over positive. We're going to end up with a negative number. My first derivative is going to be strictly negative, not strictly, but mostly negative once we get past a certain initial value. And we can say it's decreasing. Okay, so we are set on the second condition here. So it is a decreasing function. It's the limit as f of x or f of n goes to 0. So if we look at the limit as n goes to infinity, what is my function value here? We have, going back up here, we have n squared over n cubed plus 2. So we have n squared over n cubed plus 2. If you want to be real precise about this, remember what we did in calculus 1 was we multiplied top and bottom by 1 over n squared. Or, yeah, 1 over n squared. We could do it that way. Actually, we could multiply everybody by 1 over n cubed if we really wanted to do it that way. So that might be a better way to go. Let's multiply 1 over n cubed for everybody. So we're going to have 1 over n on the top. We're going to have 1 plus 2 over n cubed. We still have our limit as n goes off to infinity. Okay. And if I plug in my infinity here, we have 1 plus I'll put the zero in quotes, okay, because any 2 over n cubed as n goes off to infinity is going to go to zero. And then we have zero up on the top. So that actually does go to zero. So we're okay with saying that the limit as n goes off to infinity is going to be to zero. So by the alternating series test, we have fulfilled each of these three conditions. They all fit. So this series converges. So we go ahead and say by alternating series test. There we go. By AST. What do we have here? We have the sum of n over n cubed plus 2 with a -1 up here converges. Okay. And that's what you're looking to do. So if you want to use alternating series test, that's great. First, identify that you have an alternating series. Secondly, go through each of the conditions, make sure you've checked them off, and then you can go ahead and make your conclusion. And that's how you do those kinds of problems. Okay. Thank you very much for watching the video. I'll see you in the next one. Take care until then.